So this is the next example. Suppose that the lifetime of batteries is skewed with a mean of 170 days and a standard deviation of 10.8 days. So can the central limit theorem for means be used with a sample of 10 batteries? How about 36 batteries? So if we go back, we know that we can use the central limit theorem for means in two different cases. So if it's normal, okay, then it doesn't really matter what n is. N can be 1, 2, 3, whatever we want. Now the data is not normal. So according to this problem, it's not normal and we need 25 or more. Okay, so if we look here, for 10 batteries, this cannot be used. So CLT for means cannot be used. Okay, when n is equal to 10. Okay, so this one, no, it's a big fat no. It's too small. Since it's skewed, our data will still look skewed. It's not going to look any normal. What about with 36 batteries? So for n equals 36, we can use CLT. Okay, we can use CLT because n is greater than or equal to 25. So that one's good. Okay, so that one checks out. Okay, so now part B, write the sampling distribution when we sample 36 batteries. Okay, so when we're talking about sampling distribution, all we want is the mean and the standard error. So we know that x bar is normally distributed with a mean of mu and a standard error of sigma over square root of n. So we know that our mean in this case is what? It's 170 days. Okay, so this is 170 days. Our sigma is just equal to 10.8 days. And our n is just going to be the square root of 36. Okay, so what is this going to give me? So the mean is now 170 days. I'm going to plug the standard deviation over, so 10.8 divided by the square root of 36. That's going to give me 1.8. Okay, so that's what I got for that one. Okay. All right, and that's all I want. I just want the sampling distribution. What is one? This is going to be 170. This is going to be 1.8. Okay, so part C, find the probability that the mean lifetime of 36 batteries will be greater than 172 days. Now notice here we're talking about the mean lifetime, not the lifetime of just a random battery. We want the mean of these 36 batteries. So we know that the mean is 170. We want it to be greater than 172. Okay, so we're going to use this information that we found here to figure this out. So it's going to be normal CDF. It's going to start from 172. It's going to end at positive infinity. Okay, the standard, the mean is going to be 170, and my standard error is going to be 1.8. Okay, so now I'm going to put this into my calculator. Second data, distributions, normal CDF. Our mean is 170. Our standard deviation is 1.8. Our lower bound is going to be 172, and our upper bound is going to be a really, really large number. So my answer is going to be equal to 0.1333. Okay, that's going to be around my answer. Well, this is ugly. Okay, and that's basically all it is. This is all we're doing with the central limit theorem for means. Just the only thing that you really have to worry about, everything is still normal CDF. The only thing to really worry about is these scenarios. So if you have normal data, n does not matter. If you have not normal data, then you have to make sure that it's greater than 25. If it's not normal data and you have less than 25 samples, then you have to do something else. Okay, so really put this down on your notes because I'll probably quiz you on this portion. Okay.